Hi, I'm Farana, and today I'm going to be talking about multimodality and when it makes sense to use it. And I want to start by just taking a simple example. So what is multimodality? Let's look at this picture. It's a picture of gløgg and æbleskiver alongside a title that says, "A glass of warm gløgg alongside homemade æbleskiver on a wooden table." Let's ask this combination a question. Is this a cafe? If we look only at the image, we can see that, or at least what sticks out to me, is the way that the æbleskivers and the gløgg are plated. So there's like a napkin under the gløgg, and this is sort of plated in a fancy way like it would be at a cafe. So I'd say yes. Now if I look only at the text, I can see that it says that the æbleskivers are homemade. So I say no, it's probably a living room. In this case, looking at both modalities individually, I have non-redundant information. And in this case, what stuck out to me was the plating of the æbleskivers and like how the image sort of presented it like it would be in a cafe. So I would have dominance of the image modality when looking at the image and text pair. Let's ask another question. Is this a table setting? Now, we look only at the image and we see that it's on a table. It's something plated on a table, so we can infer yes from just the image. The text mentions a wooden table, so we can infer yes from the text as well. We have redundant information here. Both modalities are individually giving us the same answer to our question. And here, when both modalities give us the same answer to our question, but they're not really individually contributing something new to answer our question, we can have enhancement. So we're more secure of the answer to our question. The third question. Is it the holiday season? If we look only at the image, we can see that it's a winter setting. At least there's some beverage here, some pastries. There are at least cozy vibes here. So we'll say maybe. We look at the text. The text mentions gløgg and æbleskiver. Those are traditional holiday treats in Denmark. So perhaps, we could serve them not at the holiday season, but it's perhaps not that likely. We have non-redundant information again, and in this case, we could say that we have emergence. We have each modality individually contributing something unique to this representation that makes us sure of our answer when we say, yeah, it's the holiday season. My name is Thorana, and I'm a data scientist at Today. I got my master's degree here at DTU in human-centered AI, during which I spent a semester at Cornell University. When I was doing my studies, I did a multimodal learning project in collaboration with Vivino and the Pioneer Center for AI. Then when I joined industry, I did another multimodal learning project with the e-commerce platform Ønskeskeen. And today, I want to talk about the learnings from these two projects, and in the end I have a little surprise, so stay tuned for that. Now, modalities exist on a spectrum, ranging from raw modalities to more abstract modalities. And if you take a picture on your phone, that picture is a very raw modality. It's coming directly from the camera on your phone. Now, your phone has a feature that detects that there's a face in the picture. So you have a more abstract modality there, that's that face detection. And then your phone categorizes the face as your friend Susan. And then you have your friend Susan as the classified face in the picture as an even more abstract modality. When I was doing the multimodal learning project with Vivino, we introduced flavor as a modality. And that was in part because we were trying to explore the idea if we could use multimodality to make better wine recommendations. Imagine this. You have a favorite wine and it costs 500 krona. You can't be buying that wine every Friday. You need to find a cheaper alternative to that wine. Now, say you can find a wine that tastes very similar to your favorite, quite expensive wine. That is made possible if you have a flavor space for wine. In this flavor space, wines close together in the space are similar in terms of flavor, while wines further apart are not. Now, we explored the idea of making this flavor space by combining images of wine bottles alongside user reviews about the wines with human annotated flavor similarities. We did this by collecting a data set that we published with the name WineSensed. WineSensed has close to 900,000 images along the same number of user reviews, attributes such as country, region, alcohol percentage, etc., for a subset of these, alongside these human annotations of flavor. We fed the images and the user reviews into the multimodal text image model clip that then yielded image embeddings and text embeddings aligned in the same space. We applied dimensionality reduction and fusion to get them into a unified representation. But how did we get the wine flavor data? We hosted a bunch of wine tastings, many of them here at DTU, and we got over 250 people to annotate wine flavor for over 100 type of wines. What they essentially did was that they took 5 shot glasses of wine and arranged them on a piece of paper, close together if they are similar in terms of flavor, but further apart if they are not. This yielded a bunch of data points that looked like this, where we had papers with stickers on them, where each sticker represented a specific wine and the distances between them, the similarities. We applied computer vision methods to detect the dots, their color, and then we calculated the distances. This essentially yielded a distance matrix or list of pairwise distances that we processed and then yielded a representation. We combined the two spaces into a shared representation, and in this shared representation, each data point represents a wine, and its closeness to another data point represents how similar that wine is to the other one in terms of flavor. When we were doing this, we tested out a bunch of different image encoders, text encoders, dimensionality reduction methods, combinations of modalities, as well as methods to combine the two spaces together. We introduced this method as an algorithm we call FEAST. FEAST stands for Flavor Embeddings from Annotated Similarity and Text Image. Now, we found that this shared embedding space, it enhances flavor classification, so we get better accuracy when trying to predict the country, grape, region, etc. And it aligns closely with the human flavor perception. And one of our most interesting findings was also that combining all 3 modalities, images, text, and flavor annotations, enhances the flavor representation. But multimodal learning is not bound to the wine world. I also worked on a multimodal learning project with the e-commerce platform Ønskeskien. I don't know if you all know Ønskeskien, but on their platform, you can essentially make wish lists. You can copy-paste links from places that sell stuff and paste them into Ønskeskien and make a list for Christmas or your birthday or wedding and send it to your friends and family. Here, I have uploaded a link to a Mocha Master, And Ønskeskien shows me examples of other mock-masters from other providers that I can add. Like this one from iMerco, it's a bit cheaper, I can add that, or I can replace it for one at the same price from Elgiganten. This product matching logic is what we were working on improving. We're trying to answer the question, are these two products the same product? Now, let's look at these two titles. Are they the same product? They are exactly the same, except the last character, and that character is describing the size. So they are the same product if we say that the same product is the same product but different sizes. Let's look at the corresponding images. Are they the same product? They look similar, but if you look closely, you can see that the seams differ here where the pant is, and if you look even closer here, you can see that one of them are actually shorts and the other ones are long. So we'd say they're probably not the same product. Combining the images with the text, we can be quite certain that although these two products look similar and they're related, they're not the same product. We fed the product images with product titles and descriptions into the multimodal text image model clip that then yielded image and text embeddings aligned in the same space. We tested out different fusion methods to fuse the two spaces together, and we went with the best performing one. That yielded a product representation where products close to each other are more likely to be the same, essentially. We applied a distance threshold and therefore could match together products that were the same. We found that this method, when we tested it on a subset of the products, yielded 13% increase in precision compared to the already implemented product matching method on the platform. Now, multimodality, it allows systems to find relationships and correlations between modalities that don't exist in isolation. And this creates systems that have a better understanding for our environment. That makes sense because when we think about it, we go around and we see and we hear and we smell and we taste. We are multimodal. And if we want to make systems that understand our world, it makes sense that they are multimodal too. But I'll leave you with this. Not all data points add valuable information. Here are some examples of user reviews from the Vivino platform. Reminds me of riding in my grandpa's Cadillac after my grandma fed me blueberry pie. That never happened, but that's what this wine is like. Doesn't really tell us a lot about flavor. And here's another one. Not so great. If I'm desperate, I'll buy it. And this one reminds me of a Facebook status. Eileen and I liked, Chelsea was not here. This brings me to my surprise. And the surprise is that I have brought wine and paper, and there are some markers on your tables. So if you're interested, you can grab 3 shot glasses of wine from over there and do a little wine annotation of your own, where you can try being like one of the 256 wine flavor similarity annotators for Wine Sensed. Questions? Yes.
Thank you so much for a very interesting presentation. I was wondering, in the wine experiment, I can imagine that people are very biased with regards to wine. How significant was the data that you got there? Didn't you have many outliers, and it must have been difficult to process?
The data was quite noisy, and we're biased in the way that like we hosted many of them at D2, for example. So our age range was, to a large degree, people from 20 to 30, people from Denmark that have tasted maybe similar foods, and so all of these factors affect the result, but we were able to get a signal anyways, But we definitely mentioned it as something to do, in a future work to get a more diverse profile of annotators and more annotations as well.
Hello. It's because when we discuss e-commerce, the mapping of the behavior of a visitor to a site, for instance, if you were to, and this is a hypothetical question, but if you were to map that, and let's say you were to guess, for instance, which kind of visitors is there based on what they look at and how they behave, because you see the one thing is that you focus on a fact-based, but you also, e-commerce is often interesting behavior-based analytics.
Are you thinking about more like product suggestions that are similar in this case? Yeah. So that's related to the problem that I presented, but it's not exactly what we were trying to solve. So what we're trying to solve is, are they the same product? Like, can we suggest them as an alternative for me as a user to switch out just to buy that same product from another provider, maybe at a cheaper price,
Thank you for the presentation. Great examples of multimodality. You're talking about data quality in your presentation indirectly, and when you see a data collection where I assume that amateur wine tasters were sort of to label the data, you could probably guess that it would become a bit noisy, and here a solution could maybe be to invite experts and standardize the data set and the predictions that way. But what I want to ask is, in all your work, have you considered tools and strategies towards automating the way that data quality is assessed?
I haven't done that, no, but that's an interesting direction. Can I ask you, how would you go about that for example, papers, like if you have a distance thing, like what's your...
All right. Well, in one of the data sets you just showed, in one of the slides you just showed, you showed some metadata that were outliers by itself. I'm pretty sure that you could find a model that would be able to identify that automatically. So basically, having LLMs look at the data set, identify faulty, broken, invaluable data, and automatically remove it, thereby having a sort of self-healing data set that improves its own quality.
Oh, yeah, you mean for the user reviews?
In this case, the user reviews, but like we've been seeing many things today. We also saw Teton, where there's images and from image sensors, and there again, data that creates noise in the model could be removed automatically if you had systems that would detect them.
That's a good idea. And I think it's a good idea with the language model as well, at least for the text, We did do some processing before we collected the user reviews in terms of like length and so on. But we didn't go to that extent to be like checking if that user review was about flavor or not. Which
well,
also means
as
that
data sets scale, as they do, I guess that's a good thing to think about at least.
Yeah.
How can you automate the data quality assessment? Because people and labeling cost money.
For sure.
I would like to ask how you prepared the concept of your wine tasting exercise, especially on the size, because 250, I mean, what were your thoughts? And if you have to design around 2, what would the size you will aim to?
So we borrowed this method of tasting from Century Science. It's called napping. And so far that we know of, this is the largest napping collection or tasting ever to be done. We were just trying to get as much data as possible. And I remember in the beginning of the project, I was like, we're gonna have 500 people, you know, and then you're there and it's wine tasting number 8 and you're on week 3 of drinking wine every day and you're like, okay, perhaps it's only gonna be 250 people, you know. Yeah, but I feel like we could have gone on forever, you know, but it was also my master's project, so I had to start writing at some point, you know. Yeah.
Any questions online? No. So we have time for more questions. If anyone have burning questions in the room?
I'm not friends with it. In extent of your question, couldn't you just focus on the reviewers, so you actually find the expert tasters based on how many reviews you had and the content of the reviewer, and then work from there? So because if you know you have expert wine tasters, you can just focus on the wines they have reviewed. So that's like, again, a behavior focused way of approaching this problem, because then it's kind of like automatically give you better data.
So the question was about if we could have used the fact that the user is an expert user to get like better quality reviews.
You just focus on how many reviews they made, like, and if they were good.
If the user has made more than X reviews, that's a good idea. Yeah, for sure.
Yep.
Thank you for the talk. I think as a comment to the last question, taste is highly subjective, right? So, and Vivino is a business that needs to operate and earn revenue. So I think if you wanted to sell wine for experts only, it's a great idea. But really, my taste buds might be very poor compared to an expert. And then as a comment to the prior question, I actually applaud both speakers for taking action on your ideas. I mean, a lot of us can sit here and have good ideas and suggestions on what you can do better, but at least you're doing something. And I think that's very noble of you. I have one question. So in terms of the product representation, how do you determine the number of clusters when you build these representations?
So for the products, we went with a distance threshold to detect the matches. And we basically tested out a bunch of different distance thresholds and went with the one giving us the highest precision, because that's what Ønskeskyen cared most about, that we wouldn't be suggesting products that are not the same product. They care less about if we miss some matches, you know, but they just never want us to suggest something that is not a match.
Do we have a last question?
Thanks so much for your talk. I think my question will still be on assessing data quality. Is it possible to train a model that tells better on if the data is good or not than human annotators? Does that make sense?
Like if the human annotators are doing good annotations or not?
Yeah, can you have a model that does that, and actually this model does better than the supervisors of those data annotators?
I'm not sure, because if you would have a model that would be able to say if because it's how you perceive the flavor, right? It's how close together you think these two wines should taste or how far apart they should taste. So I don't think it's possible to make a model that sort of generalizes across everyone and is able to say this is a good annotation or not. If someone manages to do it, I'd love to hear about it.
Let's see. I think we do have time for one final question, if anyone have a burning one. Maybe not. Let's give Torana a great hand of applause.